Good morning, girls. Girls, let's continue with the chapter magnetism. In the previous videos, I had explained you what is a magnet, what are the different kinds of magnets, what are the different properties of the magnets. Then we had already studied about what is the magnetic field and what is the direction of the magnetic field, means how the lines of force move from which direction to which direction. And yes, now today we are going to study about the magnetic effect of electric current, right? This is the name of your chapter also, magnetic effect of electric current. And today we know that magnetism and electricity are interlinked or connected with each other. So today we are going to study this topic, magnetic effect of electric current. Now I have drawn a circuit over here in which there is a battery, a key, resistor, right? And this is a conductor. Now when the current flows through this circuit, when the current flows from positive side to the negative side, when it flows, this conductor start behaving like a magnet, right? How do we know that this behaves like a magnet? If I bring a needle, a compass needle near it, there will be deflection in the needle. Now, why there is a deflection in the needle? In the previous video, I explained you that if a compass needle is brought near a magnet, it gets deflected. So similarly, when this needle is brought near this conductor, now this conductor, the current is flowing through this conductor. So when this conductor is behaving like a magnet, because the current is flowing through it, a magnetic needle brought near it gets deflected. That means what has happened? A magnetic field has been generated around this conductor. So this effect of the current is called the magnetic effect of current, of electric current. So I repeat what has happened. There is a circuit in which the current is flowing. We take a conductor, a straight conductor XY, and if we bring a magnetic needle near it, we will see that the needle gets deflected or it shows deflection. And why does it show deflection? Because the conductor starts behaving like a magnet, or we can say that a magnetic field has been generated around this conductor. This effect of the current is called the magnetic effect. Now definitely this magnetic field will have a direction. As I told you before also, it has a direction, it has magnitude as well as a direction. Now to know the direction of the magnetic field lines or the magnetic field, today we are going to study the right hand thumb rule, right? That right hand thumb rule tells you the direction of the current as well as the direction of the magnetic field in a conductor or of a conductor. Let us study the two activities first. Okay, now I take two circuits, once again two circuits, this and key, resistor, right, and the conductor is XY. Now one more circuit I draw. Can you tell me the difference between the two? Plus, minus, plus, minus. The direction of the terminals are different, right? The conductors are same, XY, right? Now what happens when the current flows from this conductor or in this direction? Obviously this conductor will start behaving like a magnet, and if the needle is brought near it, the deflection is seen in the compass needle. Similarly here also the current flows in the circuit, right? You can see the direction of the current is different. Okay, I'll talk about this also. Again a needle, and the direction of the deflection will be different now. Now can you tell me why the direction of the deflection is different? Because of the direction of the current. Okay, in both the cases the conductors are straight conductors. In both the cases current is flowing, in the first one as well as in the second one, but the difference is that here the direction of the current is from one side, this side, and from this, in this conductor, or in this circuit, the direction is in the direction of the current is in the opposite side. So what happens? Here the deflection and here the deflection is different. Why does this happen? Because of the change in the direction of the current. That means that if there is a change in the direction of the current, the magnetic field or the direction of the magnetic field also gets affected. Okay? So this is what we are going to study by the help of the right hand thumb rule. So I hope this is clear to you that if the direction of the current changes, the direction of the magnetic field also changes. Now this type of conductor or this type of magnet which is created by the electric current is called a temporary magnet. You know why do we call it as a temporary magnet? Because if we stop the flow of the current, then what will happen? The conductor will stop behaving like a magnet. So this is just a temporary magnet. Now next, to understand the direction. Now today we are going to study about the direction of the magnetic field in a straight conductor. Today we are going to study the direction of the magnetic field in a straight current carrying conductor. So the activity is shown like this. This is a straight conductor XY in which there is a battery again, right? And here we can connect an ammeter. Ammeter shows the magnitude of the current. Then here we have a key and a resistor, right? This is the conductor and this is a straight conductor. So we are going to study today the direction of the magnetic field in the straight conductor. So as we know that when the connections are complete, the current start flowing and current flows from this side. Yes. Now let us keep a cardboard in between. Between the conductor there is a cardboard, and on the cardboard we sprinkle iron fillings. I told you what are iron fillings? Iron fillings are very extremely small pieces of iron. So when these iron fillings are sprinkled on the cardboard, we will see that there is a special arrangement. They will arrange themselves in a specific pattern, or they will form the concentric circles. Okay, and if there is a needle here, definitely it will show the deflection. So why is it showing a deflection? Because this conductor is behaving like a magnet. There is a magnetic field generated around this conductor, and if there are iron fillings brought close or kept on the cardboard, they will arrange themselves in a specific pattern of concentric circles, right? If the amount of current increases, that means if the magnitude of the current increases, the deflection in the needle also increases, right? And if I take this compass needle away, or if I say the distance from the conductor increases, the deflection in the compass decreases. This is obviously because the effect will be less if I take it away from the conductor. So we take a complete circuit. Conductor will be a straight conductor. Then the current will flow through the conductor. We can measure the amount of current flowing in the circuit with the help of ammeter. Then what will happen? If I keep the iron fillings on the cardboard, they will arrange themselves in a specific pattern. This specific pattern actually shows the direction of the direction of the magnetic field. Okay, this direction of the magnetic field is different in the different means if the direction of the current changes, then the direction of the magnetic field will also get affected. And as I told you that we will study this with the help of a right hand thumb rule. Okay, so if I take a conductor, this is a conductor, this is a conductor. Now the current is flowing through this conductor. I will show the direction of the current and the direction of the magnetic field with my right hand. So if I hold this with my right hand like this, so what will happen? My thumb will point the direction of the current and these curved fingers will show the direction of the magnetic field. Okay, so this is called right hand thumb rule. Now I can also hold this conductor in the other way. This was the first way as I did it, right? So this is the thumb shows the current and this shows the magnetic field. And if I do it like this, that means if I change the direction of my holding the pencil or the conductor, this is the direction of the current and this is the direction of the magnetic field. So as you can understand that if the direction of the current changes, the direction of the magnetic field also changes, and we can show the direction with the help of an arrow. When we are showing in the diagram, we can show from, it can be either clockwise or it can be either anti-clockwise depending on the direction of the current. So this is the right hand thumb rule. You can see once again, this is how we curl the fingers. This is the direction of the current, this is the direction of the magnetic field, and if I hold it this way, definitely the direction of the magnetic field will change as the direction of the current is now downwards. So this is right hand thumb rule. So today you will see my video carefully, you will read your chapter, I will give you the notes on this, and you will learn this topic and also revise your previous topics which I have completed with you, and learn all the important topics. Okay, if you have any queries or doubts, you can ask me. Okay, thank you.